Now dear student, we are going to discuss question number 1.32, and here again we have two parts in this question. First part is given to you, consider an arbitrary electrostatic field configuration and a small test charge is placed at a null point. Okay, dear student, do you know what is null point? Null point is a point at which we will find net electric field 0. Clear? Okay, so that the equilibrium of the test charge is necessarily unstable. It means, let's suppose if we are placing any test charge, it is highly unstable or it is in the position of unstable equilibrium. Clear? So now concentrate. Let us try to understand what is the given statement. Clear? So let's suppose actually we have to prove that if we place a charge at a null point, it is an unstable equilibrium. So how can we prove it? So let's suppose if we take here a contradiction, let's suppose we assume the charge that we are placing at a null point, that is in a stable equilibrium. It means let's suppose I am assuming, let's suppose we have any configuration we don't know. Let's suppose we have here Q1, Q2, Q3, Q4, Q5. We don't know what is the configuration, but we have a point. Let's suppose this is point P where we have net electric field 0. Clear? Let's suppose if we place a charge Q at this point. Clear? So definitely when electric field is 0, there is no net force this is acting on this charge, and we are assuming, actually we don't know, but we are assuming, let's suppose it is in stable equilibrium. Clear? So the charge in stable equilibrium. So actually what is condition for a stable equilibrium? So if we displace this charge in any direction by small amount, a restoring force will act on this charge, and this charge again try to come its original position at point P. Yes or no? Yes. It means we can see on this charge electric field will act in one direction, either this is inward direction or it is outward direction. If we have positive charge, it will act in a inward direction, and if you have negative charge, it will outward direction. Clear? Or let's suppose we can see we have charge Q. So this is, let's suppose we have a charge Q. So restoring force will act in inward direction. Clear? Now, so we can see when restoring force is acting in an inward direction from all the direction. Clear? It means we can see according to Gauss law. According to Gauss law, if we draw here a Gaussian surface, we can say there is some electric field lines that is going inside this Gaussian surface, and we can say definitely there is some electric field is to be present. Yes or no? But we know at a null point we have value of electric field 0. So actually this is a contradiction of our statement. Clear? Again I am saying to you, initially we are assumed that let's suppose charge in a stable equilibrium. If charge is in stable equilibrium, there should be, if we displace a charge by small amount, a restoring force it should act, and it should act like this, the charge again come to its original position P. Clear? When electric field is acting in the same direction, it means we can say there should be net electric field here. Yes or no? But it is given in a question, we have a null point. So it means this is a contradiction of our statement that we have assumed. Yes or no? Or we can see here definitely this statement that we are assumed that charge in a stable equilibrium, that is wrong. Clear? So we can say charge in this situation we have unstable equilibrium. Clear to everyone? Okay. Now if we talk about option number B or part number B, verify this result for simple configuration of two charge. Clear? Same magnitude and the same sign. So let's suppose I am taking here, let's suppose this we have charge Q, and let's suppose we have charge Q, and this is also charge Q. It may be, both charges may be positive, it may be negative. So definitely we know at midpoint we find here net electric field 0, or at midpoint on the line joining between these two charges we find null point. Yes or no? Because if we take positive charges, E1 and E2, it act like this, they will cancel to each other. Yes or no? So it means this is a position of null point. Clear to everyone? Now if we displace here a charge Q in a right direction, listen carefully, in a right direction, definitely we can say the charge will come again to its position P. So we can say here restoring force is acting. If we displace this charge Q in left direction, restoring force is act in this direction. So again it will come to position P. So in a horizontal direction we can say this charge is in stable equilibrium. But what will happen in a perpendicular direction? let's suppose we are taking a point P at this point. Listen carefully. So at this point P, we can see an electrostatic or electric field will act in outward direction. Here electric field is also acting in outward direction. So net electric field we will find in the vertical upward direction. Clear? It means if we displace a charge by small amount, it will go away from point P and it will never come again to point P. Clear? It means we can say in a vertical direction charge is in unstable equilibrium, but in a horizontal direction charge is in stable equilibrium. Clear? So overall, if we say that in this configuration also charge is in unstable equilibrium, yes or no? So we can say in the configuration that is related to point charge is again we can say in unstable equilibrium. Clear to everyone?